Hi Algebra students, welcome to your second digital learning day. We are going to look at more on simplifying radicals. Unlike in chapter 10 where all the radicals you were simplifying, you're just working with one at a time. Well, sometimes we want to be able to multiply radicals, divide radicals, that sort of a thing. That's where we're going to go with this unit. Just like last digital learning day, after you watch the video, which by the way you need to make sure that you complete the attached notes in the bundle as you watch this video, because I will check to see if you have those notes next chapter 11 test. I'm going to check for those in your binder check, just like we would do it for any other test. So even though this is a Saturday, even though this is a digital learning day, you need to complete your notes. They're attached, print them out, and follow along with. All right, so let's get started with this. First thing that we need to be comfortable with is that when you multiply two radicals together, you can multiply the radicands. Remember that term from last unit? That's the thing under the radical. So for instance, if I have radical 3 times radical 3, note both of which are prime numbers under the radical, both are prime radicands. So if you plug 3 into a factor tree, wouldn't take you anywhere. Well, instead of writing radical 3 times radical 3, we can say that is simply radical 9 and break that down from the factor tree as 2 3s. We can pull one out, so it's just an answer of 3. So that's going to be a nice shortcut to be aware of as we work with radicals here. All right, let's check out the first. We've got radical 8 times radical 12. Now again, you do not want to try to break down radical 8 using a factor tree, then radical 12 using a factor tree. Think in terms of order of operations here. Just multiply the two together. So this would be the square root of 96. You multiply the 8 times the 12, those two radicands, to get the radical of 96. Now that we have just one radical, now we want to plug this into a factor tree. We'll write 96 at the top. Our two limbs coming off can be, not lots of choices here. I'll go with what's easy for you guys, even though it might make for a longer tree. Divide 2 into that, knowing that 96 is an even number. We get 48 back. 48 gives us 2 and 24, again following the idea that this is even, so we can divide in 2. We'll divide another 2 giving us 12, another 2 giving us 6, another 2 giving us 3. So we've got factor pairs here of 2 and of 2, leaving leaves here of 2 and 3 that did not get circled, so those do not come outside the radical. You would write that the final answer, the most simple, the simplest form of this radical 96 will be a 2 times 2 outside the radical for each pair of 2's that got circled, and underneath the radical we'll have the 2 and the 3 that did not get circled multiplied together. So this would be 4 radical 6 for a final answer. So it's kind of a nifty trick to be able to multiply two radicands together. Let's see that one more time. This is going to save us a lot of time here. Rather than really, if you tried to break down the 8 using a factor tree, you would do so much more work than using this idea that radicals multiply together. 8 times 8 gives us rad 64. 64, I'm using the factor tree here. I think it's a nice tool. Many of you guys know what this comes out to be because it's a perfect square. Obviously that's 8 and 8. Each 8 gives you a 2 and a 4. Each of those 4s gives you 2 2's. So you got 2 2's, 2 2's, 2 2's. Obviously that comes out to be 8 for a final answer. Again, remember, when you are pulling stuff out of the radical, if there's nothing left, you don't write a radical. You wouldn't write this as 8 radical empty. You just write an 8. And there you go. There's your first shortcut, your first technique that we're going to use when you're multiplying radicals together. All right, let's check out what happens when you have coefficients for those radicals, when you've got whole numbers multiplying with the radicals here. So we have 3 radical 3 times 4 radical 7. Well, just as when you guys saw 4 times x to the second times 3 times x to the third, and you guys knew that that would be the 4 and the 3 multiplying together, the x squared and the x to the third multiplying together to give us a final product of 12x to the fifth. Here too, I'm going to erase that. This is just an example to get you clued in here. Here too, you're just going to multiply your like terms. We know radicands, the stuff under the radicals, can multiply together. We know whole numbers can multiply together. So the 3 and the 4 multiply, the 3 and the 7 multiply. So this gives you 12 radical, 3 times 7 is 21. And we're going to try to break down what we can from the 21. 21 breaks down as 3 and 7, both of which are prime. So that is as good as you're going to get it. You multiply the whole numbers, you multiply the radicands, and you pull anything out from the radical that you can. Notice here on this slide, just like on this slide, once I got it down to one radical right here, and right here, I'm going to a factor tree to see if I can pull anything out. And then it's in simplest form. Here there was nothing to pull out, so that's as good as we got it. Problem number 4, notice you've got a whole number multiplying by the radical 3. There's nothing multiplying by the radical 12. You can do one of two things. You can recognize that the 5 doesn't get multiplied by anything, or if you're more comfortable adding a 1 in front of the radical 12, you can do that. So you can multiply the 5 and the 1 to get 5, the radical 3, and the radical 12 to get radical 36. Here we've got a single radical, so we're going to go to the factor tree with the radicand of 36. That breaks down as 6 and 6, each of which is a 2, a 2, a 3, and a 3. Well, those are all the leaves we get. Each of those 6s was a 2 and a 3. So we've got 1, 2, 1, 3 coming outside the radical. So this is 5 in front that we already had, times the 2 that we just circled in the factor tree, times a 3. Nothing is left under the radical, so our final answer here is 5 times 2 is 10, times 3 is 30. And there you go. So really, it's not too bad. We're not seeing a whole lot new from what we had worked with in the past when you multiplied whole numbers and variables together. You just got to clue into what can be multiplied together. Only the quote-unquote like terms get multiplied together. All right, so let's go ahead and see this a couple more times. We've got 2 radical 5 times 6 radical 10. Here 2, the whole numbers of 2 and 6 can multiply together. The radicands of 5 and 10 get multiplied together. So we have 12 radical 50. We're down to a single radical, so we're going to plug the 50 into a factor tree. That breaks down as 25 and 2. The 25 is 2 5s. So we have 12 times 1 5 multiplied outside the radical, and we've got a lonely 2 that didn't break out of jail. So fully simplified, this is 60 radical 2 for a final answer. And there you go. Not too bad. Okay, radical 3 squared. As you guys know, squaring something means you're multiplying that thing together twice. So we can say that the radical 3 is radical 3 times radical 3. And because you've got 2 radicals here, we're going to multiply those like things together. So this is the square root of 9. Plug the 9 into a factor tree if you want. Hopefully you see that that's a single 3 that comes out. 9's a perfect square. And there you go. Again, not too bad so far. Hope you guys are doing well with this. I know I'm moving fast, but you've got the pause and rewind feature, so feel free to shut me up, pause me, or speed through it if I'm going too slow. Whatever you need. All right, so what do you do when you have variables under the radical? Well, honestly, it's not that big of a deal. We're going to treat these as 2 separate pieces here. We have the 45 we're going to treat as one object, and the a to the 6 we're going to treat as another. Notice we only have 1 radical, so at this point we're going to plug the 45 into a factor tree. 45 breaks down as 9 and 5. 9 breaks down as 2 3s. That means 1 3 will come outside the radical. So this is what we know so far. From the number part of the radicand, from the 45, we know a 3's coming out of the radical. We know let me give it some space here. We know a 3's coming out of the radical, and we know that a 5 is staying underneath. So we have simplified everything we could with the 45. We pulled everything with the number out of the radical. Well, now let's deal with the a to the 6th. Remember that a to the 6th is simply 1, 2, 3, 4, 5, 6 a's being multiplied together. That's what a to the 6th means. Well, treat this just like you would the leaves of a factor tree. Here, for every 2 that you have, one of those a's comes out. So we have 3 pairs of circled a's. That means we are going to have a times a times a, or a to the third outside the radical. So fully simplified, this radical is 3a to the third times radical 5. And that's all we could pull out. Not too bad. So basically what I want you to do with this is I want you to treat the whole number, use a factor tree on that just like we did last unit. Then for the variables, please, 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 write those out, show that you are multiplying those out together so you can think in terms of how many should be pulled out at the same time. All right, so boxed is your final answer. Number 8, you've got the square root of 27 n squared. Here too, treat this as 2 separate pieces. The number piece, we're going to put the 27 into a factor tree that breaks down as 3 and 9. 9 breaks down as 3 and 3. So you've got 1 3 outside of the radical. 1 3 we know will get left underneath. So we've dealt with the whole number. Now to the n squared, well, that is simply n times n. So we've got 1 n, 1 pair of n's. That means 1 n comes outside the radical. So 3n radical 3 is your final answer. Not too bad. So we simplify the whole number and the variables. All right, square root of x squared y to the 5th. Here too, you want to treat these. You cannot pull out x's and y's at the same time. Think just in terms of like we did with the 3 and the 5 being your convicts, your inmates in jail. They only bust out if they're from the same gang. Here too, the x's and the y's are different gangs, so they're going to bust out separately. X squared means x times x. So you've got 1 pair of x's, 1 x makes it out of the jail. Y to the 5th means y times y times y times y times y. You've got 2 pairs of y's that can break out of this jail. So you can either write that as y times y outside of the jail or y to the 2nd. 1 lonely inmate, y, is left underneath. So you have a final answer of x y squared radical y. Make sure that you do not leave your answer like this. If you've got the same variable being multiplied outside this radical, you need to simplify. So you just write that one variable a single time, in this case y a single time, then write an exponent corresponding to the number of times you multiplied that y together. Multiplied it together twice. All right, doing great. So I said that at the beginning of the video we were going to talk about multiplying radicals together, also dividing radicals. Let's get to the division part. And one thing I want to point out on this is that if you have the square root of something like 16 over 25, that would be awfully hard to find. Instead, we can find the square root of 16 over the square root of 25. We can break that in, that one big radical for the whole fraction, into a radical for the numerator, a radical for the denominator. So this would come out to be square root of 16 is 4, square root of 25 is 5, 4/5. That's, again, a nice shortcut here to make radicals a little bit easier to play with. All right, check out what you've got here on 7. You've got the square root of 11 over 49. Very hard to do as a single fraction. So we're going to break that into the square root of 11 over the square root of 49 and see if we can break that down, chunking it into 2 separate pieces here. Well, plug 11 into a factor tree, that takes you nowhere, right? 11's already a prime number, so you're not going to get anything more out of that. 49, though, on the other hand, is a perfect square. It breaks down as 7 and 7. So that means 1 7 would come outside the radical. We already said the radical 11 was as simple as we could get it. The square root of 49 goes to just a 7 here. And there you go, square root of 11 over 7. The goal, when you simplify these radicals that are in fractions, you should not have an answer look like this at the end. You should not see 3 over radical 2. That's a big no-no. We're going to talk more about that later in this unit, but for now, use that as an error checking tool for yourself. If you've got a radical left in the denominator and you think you're at your answer, some mistake was made along the way. All right, let's check out 8 here. Again, the square root of 1/25. Some of you guys may see how that would work, but easier than working with the entire fraction, the square root of the entire fraction, write again the square root of 1 over the square root of 5. Of 25 rather. So this would come out to be, well, square root of 1 we know is 1 over the square root of 25 breaks down as 5 and 5. So you've got 1/5 for a final answer. And there you go. There you go. Not too bad. All right, let's move right along here. We've got 3 slides to go, and you guys are doing great. Square root of 75 over 16. Again, tough to do unless you break it into 2 separate pieces. The square root of 75 over the square root of 16. Well, now that you've got a single number under each of these radicals, you want to go to a factor tree for each. You're going to go to a factor tree for the numerator, a factor tree for the denominator. So we're going to say 75, break that down as 5 and 15, I believe. Yeah, 15 breaks down as 5 and 3. So you've got a pair of 5s that break out of jail together and a 3 left inside the radical. So in the numerator, we have 5 radical 3. Okay? That's as good as we could get the numerator. Now the 16 here breaks down as a 4 and a 4. Many of you guys know that the square root of 16 is 4. Let's take it all the way. That's 2 and 2, 2 and 2. So we've got 1, 2, 2 2's that multiply together outside the radical. The 2 times the 2 would give you 4. Okay, at this point, it's possible that you're going to have a scenario where those 2 numbers right there can reduce further. You need to watch out for that. Here, 5 over 4, there's no number that divides into both the 5 and the 4. So our answer here, let me uncircle that real quick. Our answer here is actually 5 radical 3 over 4. That's as good as we can get that. Sometimes, though, again, these pairs of those 2 numbers might reduce further. Let's see if that happens in the next example here. We've got radical 18 over 4. Again, we're going to start by breaking this into 2 radicals, the square root of 18 over the square root of 4. 18 breaks down as a 3 and a 6. The 6 breaks down as a 3 and a 2. So we're just plugging into the factor tree. We've got a pair of 3's here. So the numerator is going to go to 3 radical 2. That's as good as we could get the numerator. The denominator, square root of 4. I don't think I need to use a factor tree on that. It's just 2. Notice again here, the 3 and the 2 are not in a position where we can reduce them further, but sometimes that will happen. You need to watch out for that. That worked out the same way in the quadratic formula. If you remember, sometimes we get an answer that looked like this. X equals 5/4 plus 2 radical 71 over 4, and we had to reduce the 2 and the 4 to be 1/2. That's the sort of thing you need to look out for here. Again, 3 radical 2 over 2 doesn't reduce further, so we're going to leave our final answer just like that. All right, where are we at? 2 slides to go, okay. Sometimes you need to pay attention to the fraction that you've got inside the radical. Sometimes you're actually going to do yourself a favor to reduce that fraction before you plug into to make 2 radicals out of it. That is to say, 88 and 11 have a common factor of 11. 11 divides into both of them, right? So this goes to square root of, instead of the square root of 88 over 11, the square root of 8 over 1, which is just the square root of 8. Well, that's a lot nicer to work with. We're going to plug 8 into the factor tree now that it's the only thing we've got left to work with to get 2 and 4. The 4 gives us 2 and 2. So I've got 1 2 that comes outside the radical, a lonely 2 that stays in jail. So our final answer here is 2 radical 2. We'll put that in a box, and that's as good as we can get it. All right, that was a nifty trick. Let's check out this 12 over 27. Some of you guys who are really quick might realize that both 12 and 27 are divisible by 3. So we could write this as the square root of, I'm not breaking it into 2 radicals just yet. I'm just simplifying inside the radical first. 4 over 9. Well, that's handy. That does not reduce further, but we can write that as the square root of 4 over the square root of 9. We know the square root of 4 is 2. We know the square root of 9 is 3. And there you are. Nice, easy answer just by reducing the fraction inside the radical first. All right, 2 to go here. Again, check out the 90 and the 5. One ends in 0, other ends in 5. Both have to be divisible by 5 then. 90 is a multiple of 10. 10 is a multiple of 5. So let's divide top and bottom by 5, taking us to the big old square root of 18 over 1, which is just the square root of 18. 18 breaks down as 3 and 6. 6 breaks down as 3 and 2. The 2 3's are going to bust out of jail or try to together. Only one makes it. So our final answer here is 3 radical 2. Again, just by simplifying under the radical first. Last one, 72 and 8, both are multiples of 8. So we'll divide by 8 to get the square root of 9 over 1, which simplifies to the square root of 9. That's easy enough, just comes out to be 3. All right, hope you enjoyed the video. Thanks for sticking with. Again, make sure that you complete the attached notes and that you also complete the homework assignment attached to this bundle. Have a great weekend, guys, and I will see you next time.